Here is a tutorial for portal frame plastic collapse mechanism. Assume that all sections are fully restrained and all members are class 1 so that the full plastic moment capacity can be attained. When the critical plastic collapse mechanism is formed, what would be the minimum required load W in terms of MP to cause plastic collapse mechanism? Then we compare the result with all the other mechanisms. Here, a portal frame is loaded. We have the same load, W. The load applied is vertical and lateral. There are three mechanisms that is considered: beam, sway, and combine. We can then pick the one with the minimum load that causes the collapse mechanism and work out MP to compare with the other collapse mechanism. Here, bear in mind is when the load is applied in the beams, we have to make sure it is not moving laterally and causing torsion pre-failure before we reach the design that we intended. So the phenomena is called lateral torsional buckling. As we see, the load is not passing through the shear center of the beam. So we need to avoid lateral torsional buckling by providing flange or slab support. We see that in my next video. If we consider the beam mechanism, there is going to be three hinges that needs to be formed to form a plastic collapse mechanism. If we only consider the load in the beam and try to work out W in terms of MP, we only need three hinges. If we try to work out the external work done, equating that into the internal work done, the load travels through the beam into the joints and forcing the joint to rotate by theta. That rotation times the moment amount MP is the internal work done. Here we've got 4 joint rotations, which is 4 times MP times theta, that is the internal work done. And travel distance by W times vertical dV, which is theta times 3, is the external work done. When we equate that, we get W, which is 1.33 MP. If we only consider the sway, applying the lateral load only, bear in mind that there is 6 unknowns and 3 equations of motions. So 6 minus 3 is 3. That's third degree indeterminacy. Hence, number of plastic hinge we need is 3 plus 1, which is 4. In the sway mechanism, there's 4 hinges that we need to form the collapse. If we equate the external work done into the internal work done, which is W times D, the distance is 4 meters times theta. The internal work done are 4 hinges that cause rotation by theta and formed MP. So MP times theta for 1 hinge for the 4, MP for theta. When we equate that, we get W is equal to MP. Here, when we consider combined case, external work done by the 2 loads equal to the internal work done by the 4 hinges, which has 6 theta rotations, we get W, which is the minimum load, 0.86 MP. When we compare these mechanisms, we get that the combined mechanism has provided us with a minimum load, which is 0.86 MP. If we try to select using that minimum load, select the members that cause a combined mechanism which is W, which is equal to 35 kilonewton meter, we find W minimum to be 30 kilonewton. Here, collapse happens when we only apply the two loads together. If we separate them, we're not going to get a collapse. Let's see what is going to happen. For beam mechanism, W is equal to 30. When we work out the MP amount, the moment that causes due to this load is less than MP, so 22.5 kilonewton meter, which is less than 35 kilonewton meter, which means this load is not going to cause collapse under vertical load only. If we consider the sway mechanism, due to sway, the MP we get is 30 kilonewton meter, which is less than 35 kilonewton meter, which means sway alone, the lateral load, is not causing that collapse mechanism. What we find is when it is combined, when we equate external work done into internal work done, what we found is MP is 35 kilonewton meter, which is 35 kilonewton meter, the plastic collapse load. So it's only when it is combined that causes the collapse. What we understand from this is that if this portal frame structure, if we keep the same member and load, and we are asked to add external members, how can we keep it? We provide bracing. The way we provide bracing is from this joint to this joint, then we can keep the member safe. We can provide a different bracing system, or we have to increase the size of the members to withstand this load. Thank you for watching. If you like what you saw and you want to see more engineering calculation, don't forget to like, share and subscribe. Thank you.